In this lesson, we are going to continue our discussion on the angle addition postulate in angle bisectors. But there are some times when I can tell you things about angles without actually saying something about the angles. Sometimes you can know what the angles add up to be, what the whole piece is, without me actually saying. And those are when we have different combinations of rays and angles. So the first one, and if you need to pause this at any time, if you're taking notes along with me, then you can just pause it until you're caught up. But complementary angles shouldn't be a new word. They are two angles that add together to be 90 degrees. Now, they can be adjacent or they cannot be adjacent. Remember that to be adjacent means side by side. So this is an example of what they look like if they are adjacent. This is what they look like if they are not adjacent. All they have to do, all it takes to be complementary is to add to 90 degrees. Now, supplementary angles are angles that add to 180 degrees. Again, same as complementary angles, they don't have to be adjacent. So you can have these right here, they are adjacent and supplementary, and these are supplementary but not adjacent. So they can add to 180 degrees and not be adjacent. So that's the only requirement is that the angles add to 180 degrees. Then we have opposite rays, and I have several examples here. Opposite rays are rays that share a common vertex, but they extend in opposite directions. Now, I want to show you the difference is these angles right here, or these rays right here, they share a common vertex, but AB and AC both go the same direction. AB starts here at A, goes towards B, and continues going forever. And then AC starts here at A and goes towards C and keeps going forever. So those share a common vertex, but they go in the same direction. These share a common vertex, these at B, these share a common vertex, B to A and ray BC, but they just go in different directions. They don't go in opposite directions. They don't go in the same direction. They just go in different directions and they form an angle. So what I mean by opposite rays and that they go in opposite directions would be this picture right here. BA goes in this direction. It stops, it has an end point at B and extends infinitely in the direction of A. And then BC starts at B and goes infinitely in the direction of C. Notice that those opposite rays also help form this straight angle that we talked about yesterday or the other day. Okay, then we have a linear pair. Linear pair and vertical angles, which we're going to talk about next. Those are two extremely important words. You're going to need to know those, and you're going to need to know them all year long. So make sure that you understand them, you know what they look like, and you recognize them, because a lot of times I'm going to say, what do you know? They equal 180. Why do you know that? Because they're a linear pair. What do you know? They're equal to each other. Why do you know it? Vertical angles. So you need to know those words and these definitions. So a linear pair are adjacent angles, which means they have to touch, they have to be side by side, and they are supplementary. Remember, to be supplementary, all you had to do was add to 180, but to be a linear pair, you have to be both supplementary and adjacent. So linear pairs will always look something like this. Notice that their non-shared side forms opposite rays, okay? And they are always going to, they're supplementary, which means they are going to always add up to be 180 degrees. Okay, notice these two angles here. So we have this angle here and we have this angle here. They are going to add up to 180 degrees. Now, don't be confused, okay? If you have a line, and I'm talking about segments, and it happens to have a segment bisector or a line that bisects it through the midpoint, this is very different. If I say segment AB, that's segment AB and BC. Those are segments. Segments never add up to 180 degrees. Where this one might say A, B, C here, it's going to say angle ABC and angle CBD are a linear pair. So it has to say angles. Angles are linear pairs, but segments are never a linear pair. So don't get confused by that. It's a common mistake. Okay, and then lastly we have vertical angles. Vertical angles are opposite angles. We said adjacent is side by side like your shoulder partner, and opposite is the person who's across from you. So they are opposite angles, and they're formed by opposite rays. Okay, now let's see what their relationship is. So if this angle is 50, these two angles right here form this linear pair. So that means their total is 180, which means this angle is 130. Then we have the same thing that happens this way. This is also a linear pair, and that means this angle is also 130 degrees. And then we have this last linear pair. We've got several linear pairs here. If that's 130 degrees and this is a linear pair, then this is 50 degrees. So here's what I want you to see. The vertical angles are the angles that are formed by the opposite rays, and they are opposite angles. So these angle pairs, that angle pair, they are both 50, and they are equal to each other or congruent. And then we have this 130 degree angle and this 130 degree angle. They are opposite each other, and they are vertical, and so that means they are congruent to each other. So the important thing about vertical angles is that they are congruent to each other. Now, just a side note, just to give you an example, they're formed by opposite rays. And so you need to recognize that, like, so these are opposite rays, but this would not be an opposite ray. Okay, so these, if I drew that straight, it doesn't look very straight, but pretend it is. So these are not vertical angles. These are not vertical angles because while they are opposite of each other, they are not congruent because they are not formed by that X that is formed by those opposite rays. Let's look at some sometimes, always, nevers with these. So linear pairs are supplementary. So we know what a linear pair is. A linear pair always looks like this. And by definition, linear pairs are supplementary. I didn't ask about being adjacent, but a linear pair is supplementary, so that is always true. A linear pair will always add up to 180 degrees. Remember that angles are portions of circles, and so that linear pair is half of a circle. That's why it's 180 degrees. Supplementary angles are adjacent. So remember, adjacent means side by side. Supplementary means they add to 180 degrees, but remember, to be supplementary, all they had to do was add to 180 degrees. Whether they were side by side did not matter. So yes, they can be adjacent, but they don't have to be, right? That's what we drew up here. These were adjacent and these were not, but they were both supplementary angles. Okay, linear pairs are adjacent. That is always. They have to be touching each other here to form that straight angle together. So they are both adjacent and supplementary. Remember that we talked, that's the definition, adjacent angles that are supplementary. Vertical angles are adjacent. Well, adjacent means side by side. Vertical angles are opposite, right? Vertical angles are opposite. They are these pieces. They kind of form those back-to-back V's. See, we've got these V's here. So those are vertical. These two are vertical. And so vertical angles are not adjacent. They're never adjacent. They are always opposite of each other. Supplementary angles are linear pairs, this last one. So supplementary angles mean that they add up to 180 degrees. Linear pair means they add up to 180 degrees and they are adjacent. But remember that you can be a supplementary angle without being a linear pair. So sometimes they are linear pairs, but sometimes they are not. So here is an example of when they are not. Maybe this is 110 and this is 70. Those are supplementary, but they are not a linear pair. So they can be, but they don't have to be. Okay, that's how your sometimes, always, and never work. So if I want to use the diagram at the right to name a pair of each of the following, you have multiple answers. So adjacent simply means that they are side by side. So I could say that angle 1 and angle 2 are side by side. They share side XC. And they don't overlap. They have a vertex at X. I could say angle 2 and angle CXE or angle 5. Remember that you can name them by their angles by their full name, or you can name them by their nickname. Angle 1, angle 2, angle 5, angle 6, angle 3. Those are some examples of adjacent angles. Here is, we'll color them in. Those two are adjacent. Vertical angles, you have to be careful here. Make sure you are dealing with your opposite rays. And so we've got one set here, right? We've got our opposite rays where we can form our X. So angle 3 and angle 5 are vertical angles. That is one example. I could also say angle 6, but be careful, it's not angle 6 and angle 1 or angle 6 and angle 2. It would have to be the entire angle. So I would name that AXC. So I could say angle 6 and angle AXC. That's the only way to name that whole big angle. And then a linear pair, what we're looking for is angles that form that straight line. So if they're going to form this straight line, they're right here, right? And there are lots, right? We have this straight line, those form a linear pair, those form a linear pair, those form a linear pair, these form a linear pair. We have lots of options. So angle 3 and angle 6. You've got angle 6 and angle 5. You've got angle 3 and angle AXC, that red angle right here, angle 3 and angle AXC, they form a linear pair. You're just looking for them to be adjacent and have that opposite ray on their non-shared side. So let's look at some math that goes with this. What is the measure of each angle if PSQ is 7Q minus 46 and QSR is 3Q plus 6? Just a reminder, this Q is different from this Q. This is point Q, this is variable Q. Okay, so let's label what we've got. So PSQ, here's PSQ, it's this angle right here. It is 7Q minus 46, and QSR is right here, QSR. It is 3Q plus 6. Now, you look at this and you're like, but you didn't give me the whole thing. Not like the other day, right? I didn't tell you straight up what the whole thing is. But I also notice that those two pieces are not congruent to each other. I don't have a bisector. I don't have a congruent statement. I don't have markings. I don't have anything. But what I do notice is that these two angles, these are angles, right? These rotations, these two angles together form that half circle, or which would be equivalent to 180 degrees. So without saying it, just by showing it in the picture, what I know is that those add up to 180 degrees. So 7Q minus 46 plus 3Q plus 6 is equal to 180 degrees. Okay, so now we just solve it. Now we have our problem. See, the problem with this one is you had to get that whole piece. Part plus part equals whole. So it was inferred in how you knew what that was. So 7Q plus 3Q, combine these as 10Q. Negative 46 plus 6 is negative 40 or minus 40 equals 180. Be careful here. What everybody always wants to do is add or subtract 40 instead of adding 40. We would add 40 to both sides, and you would get 10Q is equal to 220. Divide both sides by 10, you get that Q is 22. Now, I asked for the measure of each angle, so I need to go back and I need to substitute in that Q of 22 into those pieces. So that would be 7 times Q, which was 22, minus 46. You get 108. And then just to check it before, I know what it should be, but I want to make sure that it is. I don't want to force it. It is 72. 3 times 22 is 66, plus 6 is 72. That's 108 degrees and 72 degrees, and they do indeed add up to 180 like they're supposed to. So on number 4, when you look at it, there are several things that you have options to do. And so I want you to make sure, like you can, sometimes you just have to write stuff down until you can figure something out. These two angles right here, if you look at it, see how they form that straight angle. Those two together add up to 180 degrees. But this plus this equals to 180 doesn't do me any good because I have a y and an x. So that's not a good starting point for me. So while I'm thinking about linear pairs, I am going to look at this one right here. Notice I have this linear pair also. This angle plus this angle equals 180. So I can set it up like this. 2x minus 17 plus 63 is equal to 180. That's not the only way to look at that problem. You could also know that, well, if this is 63, 180 minus 63 is 117. So you could have started here. 2x minus 17 has to be 117. Now you'd get there. Right here, if you took that minus 63 and minus 63, you would end up right here. So you can kind of do that thinking over here, or you can do it over here. It doesn't matter. So then you get 2x, add 17 to both sides. Then you would get 2x is equal to 134. And 134 divided by 2 is that x is 67. So I ask you to solve for x and y. I've solved for x, so I'm good with that. I can stop. Now I need y. Now, we can either go here and use this linear pair, or we can also use these two angles here, which are vertical angles. Vertical angles are always a great way to go. It's the easiest way right now. So y plus 23 is equal to 63, and you would subtract 23 from both sides. You would get that y is equal to 40. Those were the two answers that I was looking for. And I could go in and find all the angles. Well, I know this is 63. I know this is 117. Just because I knew that one was 63, I can find all 4 just by knowing that 63 like I did in the example on the front. Okay, last one. Angle 4 is congruent to angle 5. Okay, we stop right there and we need to mark that. Angle 4 is congruent to angle 5. And angle COE is 160. Here's angle COE, and it's all this space, all that rotation in between, and it is 160 degrees. So I'm asking for all of the pieces. So here's what I recommend. I recommend that you do all of your work over here and then go fill in the blanks. Because if you get it labeled on your picture, it makes it a whole lot easier to have to like not remember all of what you're trying to think. It's like, well, I already found that. Go back and find out what it was. Just write it down. Well, if these two are equal to each other and this whole angle is 160, that means that each angle has to be 80 degrees so that they can be the same size. So now you start working your way around and you have choices, and we don't all have to go in the same direction. Some of you might see angle 3 first. Some of you might see 1 or 2. Some of you might see 6. So you can look at it this way, like here's 3, 4, and 5. Those add up to create that straight angle. So those have to add up to 180. You can do the same thing. You've got these right here. Those all add up to 180. The other thing that you've got is you've got these that form this X right here, those vertical angles. So 4 is congruent to 2 because they're vertical. 1's congruent to 5 because they're vertical. It all just depends on what you see first. Typically, I would see 1 and 2 simply because I've been dealing with that 80. So angle 1 is 80 degrees, angle 2 is 80 degrees, and then you can look at your linear pair however you want to see it, whichever one you want to look at. 3, 4, and 5 add up to 180 degrees, and so since those are 160, then this one has to be 20, and then 3 and 6 are vertical, or 4, 5, and 6 add up to 180, and so then that would be 20 either way. Then we can go over here and fill them in, Angle 1 is 80 degrees. Angle 2 was 80 degrees. 3 was 20 degrees. 4 was 80 degrees, and 5 was 80 degrees. 6 was 20 degrees. AOC, so now we need to see where AOC is. So we go A to O to C. So AOC, the angle addition postulate, says I can add those together. So 80 plus 20, AOC is 100 degrees. EOC, well, EOC is the same as COE, so it's 160 degrees. And then AOD, if I trace AOD from A to O to D, those form that straight angle, or 80 plus 20 plus 80 is 180 degrees. Okay, it forms that straight angle all together. So vertical angles are always congruent. Linear pairs are supplementary. They are different because vertical angles are non-adjacent and linear pairs are adjacent.